Hi class, today we're going to talk about section 6.2. So remember that a monomial is a polynomial with one term, right? So for example, negative 5x to the fourth is a monomial. And a binomial is a polynomial with two terms, right? So remember an example of this, 3x squared plus 2x. The plus separates the two terms. Remember, terms are created from multiplications here, okay? Now, in these next two sections, we'll focus on what we call trinomials. And trinomials are polynomials with three terms. So remember here, pluses separate the terms. So this polynomial has 1, 2, 3 terms and is an example of a trinomial. Okay, when we multiply many binomials together using the FOIL method, the result often is a trinomial. This is because we can combine middle terms. So let's look at an example. If I take the binomial 2x plus 3 and multiply the binomial x minus 5, using my FOIL method, the middle terms give me a degree 1 and a degree 1 term, negative 10x plus 3x, and I can combine that to become a single degree 1 term, negative 7x. Now we want to reverse this process and write trinomials as a product of two binomials. And this is called its factored form. Remember, factored forms are just multiplications. We will first begin with the case where we have a trinomial that looks like this. So we are going to generically represent numbers b and c because we can plug in different b's and c's. So we will have a degree 2 term, a degree 1 term, and a degree 0 term here. And the degree 2 term is always going to be the single x squared, not any number in front of it. We'll talk about when a number is in front of it later on. Okay, so notice that the FOIL method is just the distributive property in disguise, right? So remember that we want to take the first term times the first term and the last term, right? Because this gives us our F and O, first and outer, right? So really we can think of that as taking the first term times the entire second polynomial, and then our inner term and last term, inner last, is going to come from taking the second term times my entire second polynomial. And then I can distribute x squared plus 6x, and I can distribute 4x plus 24. Now notice we're in that scenario where the middle terms combine to become a single degree 1 term here. Okay, now notice if we reverse, let's skip this. If we reverse the last 3 steps, this step, and this step, it's exactly what we've done. This is our factoring by grouping. Notice we have 4 terms, and if we look at the GCF here, we see that the GCF is x. What's my leftover? And then the GCF here is 4. What's my leftover? Here's my common binomials, and then my leftover. Okay, so the trick is going to be to turn this into this. And the question is, how do we do that? Okay, so let's try to factor the trinomial x squared plus 9x plus 18, okay? And we're not going to give a reason why we do this, but we're gonna see that it works, just to start with. Okay, so notice I'm going to rewrite my middle term here. And I'm going to rewrite it using 3 and 6. Notice 3x plus 6x is really 9x. Okay, so now I substitute that And now I have a 4-term polynomial. 1, 2, 3, 4, right? So now what I'm gonna do is I'm gonna factor by grouping. Okay, so let's look at the first two terms. X squared and 3x, what's in common? X, and then what's left over? If I take away an x, I have an x. If I take away an x, I just have a 3. What's in common with 6x and 18? And we all say 6, right? So take out a 6, what's left over? I have an x and a plus 3. Now here's my common binomial. Pull it out. What's my leftover? X plus 6. Right? So we've now factored this trinomial by rewriting the middle term and using our grouping method here. Okay, so the trick to make these problems work is how we split the middle term. So the question, you may be sitting there asking yourself, well, Dr. J, why did we pick 3x and 6x to become 9x? Why didn't we pick something else? And this is a typo. Something else like 4x plus 5x, right? 4x and 5x gives 9x. Or why didn't we pick something else like x plus 8? This should have been an x plus 8. 1x plus 8x still gives us a 9x. Why didn't those two work? Well, the answer is because the only thing that works is 3x and 6x, okay? And now the new question is, how do we do this? Oop. Okay, so to find the correct way to split the middle term, we will use what we call the AC method. So if you Google this or put this in YouTube, there's tons of material on what's called the AC method. The way this method works is we find a pair of numbers that multiply to a certain number and add to another number. Okay, so in our previous example, notice that we chose the pair of numbers 3 and 6, right? Now these numbers multiply to give us 18 and add to give us 9. Let's look at the polynomial, the trinomial that we were trying to factor. X squared plus 9x plus 18. Notice that these numbers appear in our trinomial. Notice that the product 3 times 6 appears as our constant term. And the sum 3x plus 6x appears as our middle term, right? Our degree 1 term. So we're going to focus on those two numbers. This is going to be our trick to factoring trinomials. Okay, so let's try to factor the trinomial x squared plus 7x plus 12. Okay, so we're going to focus on two numbers. This is going to be our method. We're going to focus on the middle number and our constant term, the last number, 7 and 12. What we want to do is we want to find a pair of numbers that multiply to 12 and add to 7, okay? Okay, so if we're multiplying, we need to look at factors. Remember, factors are how we multiply. So what are all the possible factors of 12? We have 1 and 12, we have 2 and 6, and we have 3 and 4. Okay, now we should notice that 3 and 4 stand out because 3 plus 4 is going to give us 7, right? And we're looking for numbers that multiply to 12 and add to 7. Okay, so what we're going to do is we're going to use that pair to undo the middle term. Notice now that I can rewrite 7x as 3x and 4x. I'm using that pair, 3 and 4, to undo it. Now I'm going to try factoring by grouping. Looking at my first group, I can pull out an x, and I have an x plus 3 left over. Looking at my second group, I can pull out a 4, and I have an x plus 3 left over. Now I have my common binomial, and I can pull out my common binomial, leaving me with x plus 4 here, right? So this is going to be our trick to solving these problems, to factoring trinomials. Okay, let's look at a little bit more tricky example here. Because the last example, we had all positive numbers. Now let's start talking about if negative numbers come in. Okay, so let's look at the trinomial x squared plus 2x minus 24. Okay, now we need two numbers. 2 and negative 4, right? Remember, we always focus on our middle and our last. Middle and last, okay? Now we want to find numbers that multiply to give us negative 24 and add to give us positive 2. Now we remember, if we're multiplying and we need to be negative, one number has to be negative. So first of all, let's list the factors out of 24, positive 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6. But since we're looking at negative 24, one of those numbers in the pair has to be negative. So I can have negative 1 and positive 24, or I can have positive 1 and negative 24. Negative 2 and positive 12, or 2 and negative 12. Negative 3 and 8, 3 or negative 8, negative 4 and 6, or 4 and negative 6. So now I have a lot more combinations here. And I want to find the one that adds to 2. So which pair can we add together to create the number 2? I'll give you a second. You can pause the video here and stare at it. And we should eventually notice that this is our pair. Notice negative 4 and 6, or 6 minus 4 gives us 2. So that's what we're going to focus on here, right? 6 and negative 4. Okay, so what we do is we're going to use those two numbers to undo our middle term. 2 is really 6 minus 4, right? So 2x is really 6x minus 4x. Now we group. So I'm going to group, right? Pull out an x, left over x plus 6. Now we group. Remember, this is one of our scenarios where the first term is negative. So the greatest common factor is 4, but the first term is negative. I'm pulling out a negative 4. So don't forget that trick. Now I have my common binomial, and I can factor out my common binomial, okay? Okay, let's look at another example now. Now I'm going to move the negative from the back to the middle here. Let's look at x squared minus 5x plus 6. So again, focus on two numbers. Which two numbers are we focusing on? Negative 5 and positive 6. We want to multiply to 6 and add to negative 5. So let's look at the factors of 6. The factors of 6 are 1 and 6 and 2 and 3. But notice that all of these factors are going to give us positive numbers when we add them, right? 1 and 6 gives us 7, 2 and 3 gives us positive 5. But we need to add to become negative 5. So we need to remember that positive numbers can also be created by a negative times a negative. So we need to consider negative factors too. So really, we have 1 and 6, or we have negative 1 and negative 6. Those both create a positive 6 when multiplying. We also have 2 and 3, or negative 2 and negative 3. And it turns out that we see negative 2 and negative 3 work, because negative 2 times negative 3 is 6, and negative 2 minus 3 is minus 5. So that's how we're going to split the minus 5. Minus 5 is going to be minus 2 minus 3. Now we group. I'm grouping the first terms. Get that common factor. I'm grouping the second terms. Remember, again, the first term is minus, so our greatest common factor is going to be minus. and then I'm pulling out that common binomial. Okay? Now you may want to pause the video, look back at the last couple of examples, and make sure you're on board before pressing play. Oop. Okay, so you may have noticed a shortcut for our factoring. Once we identify the two numbers, these are the numbers in our factor. Okay? And that's actually the trick. Once we find the numbers that appropriately split it, those are our numbers. Here, and let's go back even. So our first example, if I can click, notice how did we split 7? We split 7 into 3 and 4. What are my factors? A positive 3 and a positive 4. Because that's how I split it. Let's look at our next example. What was our next example? We have a positive 2. How did I split my positive 2? 6 and negative 4. How did this factor? 6 and negative 4. Finally, how did I split my middle term, negative 5? I split it as negative 2 and negative 3. How did I factor? Negative 2 and negative 3. Right, so that's actually a trick to these trinomials. It's always going to be x plus my first number that I used to split times x plus my second number that I used to split. Let's look at a more tricky one here. 3x cubed minus 15x squared minus 42x. Now, a lot of times students will go, oh, look at my first and my last. But this is a special case because we have to notice right away 3x cubed minus 15x squared minus 42x, they all have something in common. So whenever we're factoring, we always want to default to our beginning stages. Can we factor out a greatest common factor? And in this case, yes, we can. The previous cases we couldn't, but this case, they have a greatest common factor. So what's my greatest common factor? It's 3x. So if I divide, my leftover is going to be x squared minus 5x minus 14. Now, what do we notice here? This looks like something that we've been working on. This is one of our special trinomials. Okay, so now I want to focus on negative 14 and negative 5. So the question now becomes, how can I factor this trinomial? Okay, so I want to multiply to negative 14, and I want to add to negative 5. So to multiply, one of the factors has to be negative. So my factors are 1, 2, 7, and 14. So I have different combinations, negative 1 and 14, or 1 and negative 14, negative 2 and 7, or 2 and negative 7. Which ones add to 5? We should notice the highlighted ones add to 5. Negative 5. 2 minus 7 is negative 5. Okay, so that's how we're going to split. So really the trick, we can ignore the factoring by grouping. We can use our trick. This trinomial factors into x plus our first number we use times x plus our second number we use. So it factors into x plus 2, x plus a minus 7, or just x minus 7. Because remember, plus a minus stays minus. But don't forget the original problem. We had that original greatest common factor. So this trinomial factors as the greatest common factor, and then how we factored the leftover, which was a trinomial, x plus 2 and x minus 7. If you have any questions on this video, please email me. Again, Layla is available on the first floor in the study center, and she's available through email as well.